Hi, my name is Tamanda, and today I'm going to show you the student dropout prediction project that I built using image data. So, this project basically builds a machine learning pipeline that predicts the dropout of students and predicts the risk at which students can likely be dropouts based on image data. So basically, facial expressions from students in classrooms. So we use this data to find out if someone is likely to drop out of school based on how engaged or not engaged they are in class. So I built this project using several machine learning tools, and some of the technologies I used are Python and a lot of Python libraries. So, for example, I used the Flask API to build an API and endpoint, and I used Streamlit to build a user interface that is like a dashboard, and also used like Locust for load testing, and used the Jupyter notebook to build my model. Yeah. So actually, I evaluated the models using accuracy, precision, recall, and the F1 score. So my model is basically I used the transfer learning model because I think it was necessary for my image with my data set of over 2,000 images, and I took my data set from Cargo. Yes. So I'm going to show you my model and all the metrics that I track. So I actually made some optimizations. For example, I used Adam as an optimizer, and the data points have two classes, which is like engaged and not engaged. So since it's a classification model, so I think that was necessary for me to be able to predict if a student is likely to be a dropout or not. Yeah, so I was able to evaluate these metrics. So in terms of accuracy, I found an accuracy of 0.97, and it was the same with precision, recall, and the F1 score. So even like after doing the model retraining check, I found out that the text accuracy is very sufficient. So I think there was not even like a need for me to retrain the model again. So after training this model, I then saved it as an H5 file, and then I used that to build an API with 5 endpoints. I don't know, there's an error right now, but I deployed the API to render, and it usually shows me like 5 endpoints. So I use that same API to build this dashboard. I use the data from the API to build the dashboard, and also like be able to track the model uptime, and also like how long the API has been up. So for example, this dashboard takes in it queries data from the API. So, for example, the API was created one day ago, 4 hours, 1 day and 4 hours ago, and it shows how long the API has been up, and these are lively updated based on when you open the dashboard. So I actually deployed this front end on Streamlit, just that the link that I shared is has a lot of bugs, but this is how it looks. Yes, and I also like have a visualization of my data class distribution, and it was the same in the model file in the Jupyter notebook. So I said, I have two classes: the engaged and not engaged. And every single time I put in data and then I train it, this is how it's always going to update. So it's going to update the loss and also like the accuracy over the number of epochs that you use to train the model. So I also like to show it also shows the live prediction. So for example, I can upload a file and then find out which class could it belong to. So for example, if I take an image of myself looking straight forward to the screen, I'm going to look at, let's see what is going to predict for me. So it says my prediction is that the image looks like someone who is engaged with a confidence of 0.95%. Yes, so that's the result. And there's another section of model retraining. So this is whereby you retrain the model, and then like every single time you want to do a prediction, you use the data from this trained model. So, for example, I can just upload a zipped file to this dashboard, and then I'm going to be able to what to train the model, and then let's see, yeah. So it shows me that the retraining was successful, and the message shows that the model retraining process was initiated, and it's going to happen. So all this happens with the help of the API that I created. Yeah. So I also tried to use Locust to kind of like try to simulate a local simulation to see like how many requests and how many of the requests have failed, and some of them that the ones that I predicted and the ones that are like aggregated. So I think this didn't work well for me because all my predictions didn't went so well, because at the end my my API started failing. But then in terms of prediction, it works very well. But I don't know why it's not working with the locust. But I actually learned something about like how locust like usually queries the number of maybe visits and the requests that you make on your API endpoints. That's something that I've learned from that. So the conclusion is that um, I've really been able to learn a lot about building a machine learning pipeline. So from like building a model to finding out like to like merging that model with a pipeline and all that. Thank you so much.